Okay.
But in Burlington, you might be worried.
Okay, well, they don't listen to me anyway either, so. So if you're wondering, this is the slide we're on, okay? And you might be like, dang, how'd you remember from a week ago? Well, I didn't. After I finish up lecture, I usually try to post my lectures, which I was a little bit behind this week. But the other thing I do is I go and I put the word Thursday on the next slide, usually. So we've been talking about thunderstorm cells. We started with a simple air mass thunderstorm cell, abbreviated TS, right? And then we upped it to supercells. And so one of the things you're going to want to know are some features of thunderstorm cells. So I'll just put the word TS here. Okay, is it a supercell? I don't know. But notice that actually this is the third segment in 3 segments we're talking about in this chapter. And we are talking about tornadoes. Tornadoes are notorious if they're going to drop probably from a supercell is what they drop from. Remember, supercells actually have the updraft. Okay, let's see, how do I do this? The updraft, so we could actually have inflow here. This is my updraft. And your author uses blue for the downdraft, kind of wrapped around the downdraft. The downdraft is associated with the precipitation. So a few things. I like this figure because they actually draw in the tropopause. And oftentimes, and we did see a little bit of this afternoon, you kind of see this flattening out of your cumulonimbus cloud. It's bumping up against the tropopause. If it shoots into the stratosphere, actually instead of penetrating chops, we've been calling those overshooting tops. Same thing. And they look like kind of this cauliflower. You just want to go crunch. Okay, we talked about mantis clouds kind of on the other side, underside of the anvil. Let's see, what else did we talk about? That might be about it here. Here we go. There should be some, let's see if I can move this over. There should be a mesoscale. There should be some sort of rotation. I'm going to kind of move this over, kind of coming down. Mesocyclone, final answer. That's what I was after. Kind of that swirliness is probably what's going to be right above your tornado. I'm kind of liking this one too because your author draws probably what is referred to as a wall cloud. And I think we talked about those last time. Wall cloud. Tornadoes may or may not have a wall cloud to drop down from. And that whole wall cloud is kind of rotating. So there you go, tornadoes. So tornadoes, actually, I have a figure coming up here to show you worldwide where the tornadoes are. And North America, we get our fair share of tornadoes. And I think I've heard it described because we have kind of 2 mountain ranges on either side of our continent that do well with bringing air masses together, okay, that create supercells that we might get tornadoes from. So if you're like me, you kind of grew up to them talking about tornado alley, tornado alley, tornado alley. So let's just go ahead and take a look at where tornado alley is. There's an old tornado alley and a new tornado alley, actually. So a lot of these links I did go ahead and post under the Twitter feed like a week ago. But Tornado Alley, it does include, it's bigger than it used to be. And now it includes us. It didn't always historically include us. All Tornado Alley just means is there's lots of tornadoes that happen there. It's coming up, coming up. Yeah, I have too much stuff open. There, okay. So you guys can see this figure here. Okay, the dark is the old Tornado Alley, and the kind of the light colored is the new Tornado Alley. So as you can see, we weren't really in the old Tornado Alley. But This should make sense when I kind of show you all the little red dots where tornadoes form. I figure from your textbook.
So just, why does it break off and go to Florida?
I don't know.
It's weird.
I don't know. That is weird. So each of the dots is kind of a set of tornadoes. So, yep, you have some in Australia along with the poisonous animals. They also have,
Man, Australia just doesn't seem fun.
yeah, I still want to go visit.
Tokyo.
They also have tornadoes. Okay, but check out North America, right?
Japan seems to get quite a bit per capita as well.
Yeah, considering it's kind of
Wait, is
small,
that
that's
Korea
true.
or is that China? It's Japan.
So, Japan, right?
No, I'm talking about
No,
the main one.
there are 2 dots in what seems to be North Korea.
Yeah.
Because that's not South Korea.
No, that's probably North Korea. I don't even know how they got that data.
I don't know. Well, that's one thing about scientists, and that would include meteorologists, is they really kind of talk together, you know. So I don't know. The whole thing about weather, and I'll hopefully convince you this when we talk about weather forecasting, is we are all in this together. It's like stuff that we need to know what's going on all throughout the world in order to understand what's going on here. So this actually emphasizes, and I have another slide to kind of show you, if I were to ask you when do we have the most tornadoes, this is kind of showing you what, June, May, June. But it kind of depends upon what part of the country you're living in as to where your tornadoes are. So this actually is, looks like a 50-year period, or I don't know, 1916 to 1969, kind of showing you, I think your author was from Illinois, kind of showing you where the tornadoes were in the tracks. But I have some other things that are more pertinent. I've got some more websites. So NATOs is the affectionate term for tornadoes, or unaffectionate term. So, oh good, looks like that's going to open up. I thought this was interesting. Go faster. For Iowa, it's like historically, and I think the top it says how far it goes back. This is Des Moines County. Looks like the first year is 1963 to 2011. If I go search for Lee County, you know, they'll show you all the tornadoes in Lee County. So one of the things you already knew before you took this class was that we, of course, categorized tornadoes using now the enhanced Fujita scale. It used to be just the F scale. Now it's the EF scale. So I was looking at this at my office, and here it is on the Fujita scale. Okay. Anybody know what the top number for the EF scale is, or even F scale? 5. It is a 5. That's right. So here we have actually, you know, category 2, 3, 2, question mark. Category 0, I'm not sure how that works. Okay, but you have the corresponding, no one was killed, you know, and all that. Got some other websites. Oops, go back. Parkersburg tornado in 2008. Actually, this is a video. Serious stuff. I think this came out, middle of March. It says El Nino tends to subdue Atlantic hurricanes. And then it goes on to talk about tornadoes. And it says that there's a fairly strong connection between La Nina and tornadoes. So that's what I was going to show there. That's okay. Okay, so you've probably heard these stories about what the weird winds around a tornado. Just looking at Parkersburg and Joplin, Missouri, I mean, things get flattened and strange things happen in those tornadic winds. So, for instance, with regard to transporting things down the road, a small airplane wing was blown 10 miles associated with the winds of a tornado. Okay. I didn't know what a gravity wagon was, so I had to go out and look it up, but some of you maybe already know. It's like these things that you see that you have to watch out for on the during harvest season. But one of these was blown a mile down the road, associated with winds of a tornado.
Probably just no other way.
There's a difference between tornadic wind, like rotation wind, and what they call straight line wind. So this would have been picked up. And so there's your gravity wagon. I do not know why they call it a gravity wagon, but I'm sure there's a reason for that.
Because there's not no other in it.
I don't know. So odd things, a mattress blown 40 miles, and I think we saw this on a table that of weird facts about tornadoes, that actually a personal check was relocated 223 miles down the road from a tornado. So
Did they use that check?
I don't know. I went ahead and, in the vein of looking up, weird stuff on the internet, I just typed in strange tornado pictures, and so this is what my Google search showed. Like this came out of, like that's a shower. Oh, go back. Yeah. I guess that's strange. Things that tornadoes can do.
Little McDonald's sign.
Yeah, the McDonald's sign is cool.
No, the piece of wood through the concrete curb is awesome. It's just above McDonald's to the left.
This one?
Nope.
Oh, left one more.
Oh, yeah. That is weird. You're like, really?
Imagine what that do to your body.
The flag in a tree? The car hovering? You're like, really?
What is it hanging by?
Well, I get, maybe they're
it's being picked up by a crane.
That's right.
No, she's looking.
Okay, so that's not so strange.
Maybe that F-150. See, that's why they should have bought a Chevy.
That's vandalism. McDonald's are not allowed.
I think that's funny.
Is that a tree branch through a bathroom wall? I don't know what this is. What is this?
I don't know, I can't. It says damage included a sock being driven through the hood of a Toyota pickup truck.
How crusty was that
Yeah.
sock?
It's soccer sense.
Yeah, that's kind of neat.
Sock on my bedpost.
That's cool.
Yeah, I agree. So a lot of times, you've heard it's not just one tornado, it's like several tornadoes. Several tornadoes associated with maybe several supercells, heaven forbid, and then we end up with an outbreak of tornadoes. So in 1925, a long time ago, outbreak of tornadoes, and these links actually I do have under the Twitter feed, I'm pretty sure. In 1974, there was a tornado outbreak of 148 tornadoes. 30 of them were F4, F5s. You're like, dude. And actually, this is the link that talks about La Nina being in place during 74 and actually 2011. And we think of 2011 as being a lot of tornadoes, but they kind of compared this season of 74 with 2011, and 74's got a lot more. Well, let's just move on. So tornado outbreaks.
Durango with the tree going in the backseat.
I don't have patience for this. Ooh, come back. Okay. tornado outbreaks. In 1999, an outbreak killed 54. Now, when we talk about the people that, for instance, issued our watch, I get my watches and warnings mixed up. Like, watch is not so scary, right? Warning is really bad. So the folks that issued our watch actually are from Norman, Oklahoma. And they have had their fair share of tornadoes pull through Norman, Oklahoma. I just almost think they have a personality, right? So this is the 1999 tornado outbreak, and each color is a different storm. You can kind of see Oklahoma City in the middle there. So we mentioned, you guys told me the F5 is the highest or the fastest winds. And instead of using a Fujita scale, now we use an enhanced Fujita scale. And it's still 0 to 5, but it's EF scale instead of F scale.
Why did they change it?
I'm not sure. I don't know. I think I've heard, but I can't remember. So the statistics right there in the middle with the 69, 29, and 2, actually that's for weak tornadoes, moderate tornadoes, and very violent tornadoes. So those F4s and F5s that we saw, that one tornado outbreak in 1974, actually they're only 2% of all tornadoes are that crazy, okay? Most of them are weak. So tornadoes are different than hurricanes in that actually, in order to classify them, what they do is they look for the damage afterwards. Okay, so based upon the damage, then they can actually estimate the wind speed. There's more people killed. Okay, so more people killed, and we have less tornadoes compared to here. But you know what's coming, right? Those F4s and F5s. So that accounted for 2%, and it looks like this.
Dun dun dun, non-existent.
So what we have is we have noob, average player.
So how many deaths do you think are going to be from F4s and F5s? High. Very good. Go back. There we go. Yep, very good.
That's
Almost 70. Yep.
One.
Yeah.
So there aren't very many F4, F5s, and yet you have all those people die.
Solid KDA.
So yeah, I thought it's kind of ironic that today we, and we're going to look at something called the outlook, the convective outlook, and yeah,
How many people die a year from getting hit on the head with hail?
probably not very many.
Because I could imagine big enough hail could make somebody's head explode.
I've never heard of
56
any
people die a
fatalities
year by
from
vending
hail.
machines.
Yeah. Vending machines are more dangerous than sharks. Kill more
Sure
people
thing.
per year.
Not hippopotamus.
Yeah, because people shake them because their stuff gets stuck in
So
them.
back to tornadoes, right? That warning that we got, that watch that we got came from these guys, the Storm Prediction Center
There was a warning though.
in Oklahoma. Really, for what county?
Washington.
Okay. The warnings come closer to the event. Actually, warning means that they've actually seen severe weather. And remember, we talked clear back in the first part of this chapter that severe weather is defined by, 58 miles per hour wind. Your hail has to be a certain size, and it has to be known to spawn tornadoes. Then actually you'll get a warning. Okay. So around here, you guys might have Peoria and I don't know if, yeah, the Quad Cities. Yeah, both of you guys are coming. Yeah, ours I know are out of the Quad Cities.
In Hamilton, they come from St. Louis.
St. Louis, okay. National Weather Service. So-
right now, for the record, it looks really nasty by Davenport.
By Davenport.
I'm actually heading that way a little bit.
It's above
today
Davenport,
because
you're
my
fine.
sea
I was
stars-
serious.
So these convective outlooks actually, even one thing to think about convective outlooks, even when there's no severe weather on the horizon, people are out there discussing convective outlooks. The word convective might give it away. Convection means is basically that warm air rising. So convective outlook, they're looking at instability in the atmosphere. And so actually a bunch of geek weather people get together and kind of kick it around. There are blogs out there for them to kick it around. But they put out these things called convective outlooks. That will be for day 1, day 2, and day 3. And I kind of mentioned you have to kind of know what's going on all across the world and the different elevations to kind of understand where the instability could be. So Weather Underground, I think, does a good job of just kind of relaying this information. Okay. So this would be out of Norman, Oklahoma. These would be your general warnings. I think they're updated in the morning. My goodness gracious.
I told you, you're naturally good with me.
Come on. All right. Whew. An enhanced risk of severe thunderstorms is forecasted today or tonight. So let me try to get my...
Okay, I have a serious question. I looked at the weather radar. I'm going to show you this exact picture. And it says there's snow and ice in Iowa.
Interesting.
No
I
BS.
can't speak to that.
Northern Iowa?
Look at that. They have the same temperature as we do.
So let's finish up the chapter, shall we? Like we really care. So look, this is actually a figure from your textbook, and these circles kind of show you like where the stuff's happening. You also have to have like a little answer key. Of course, high, moderate, or slight possibility. For various things. The first one is just any severe weather. The other one is for tornadoes F2 or greater. Again, these are just still shots from your textbook. This is for damaging winds, for the same time. So these are actually the same thing that if the internet were being so dumb, we could just kind of pull up right now. Okay, so tornado safety. It's different than lightning safety. I don't know if you've heard some of these. Basement, obviously, if possible. Otherwise, an inside room, lowest level. If you have a mattress handy or some sort of padding thing, protect yourself. If you're in a mobile home, leave. Okay. If you're driving a vehicle, get off the road, seek shelter.
Get into the ditch.
And yeah, get as low as possible away from the roadways. Watch out for flying cars. So one of the last major things to talk about, aside from water spouts, is this idea. Now, there's regular radar, and then there's Doppler radar. Regular radar, we're used to showing kind of greens for precipitation, yellow for more precipitation, red for lots of precipitation, right? Doppler radar does something a little bit different. It uses what we call the Doppler effect. And in astronomy, we talk about the Doppler effect in that it actually can be used to... get back here. The Doppler effect can actually be used to gauge stars, if stars are moving towards us or away from us. The Doppler effect is something you're probably already familiar with. If you're standing stationary and you have a car moving towards you, you might hear the car kind of, and as it moves past you, basically when it's moving towards you, the wavelengths are getting shorter, so the pitch is getting higher. And when it's moving away from you, the pitch is getting lower because the wavelengths are getting longer. So it's a Doppler effect, and it works quite well. So what we do, or what they do actually, is use the Doppler effect with precipitation. The beauty of Doppler radar then is it can give you basically motion of precipitation. And where that comes in handy is to look for rotation within your precipitation. Okay, so that's the Doppler effect. So here we're going to look at a couple of screenshots of a storm system that actually has spawned a tornado. This is regular radar, and this other one is going to be Doppler radar. Now, Regular radar, of course, you see the green is normal precipitation, the red is nasty, right, and the yellow is bad. So we have a lot of nasty precipitation in the center there. Ugh, my thing's not working. So when it comes up here in a minute, on the right will be the Doppler radar. So the deal with the Doppler radar is it doesn't have as many colors, and when you see any sort of signal, that's precipitation. But the red and the green, think of it this way, they are going different directions from the radar. So what does that mean? It means basically in a small amount of space, you have something that's moving towards you and something that's moving away. And I can never remember, so I'll read this caption. Green represents motion towards, and red is away. So basically in a pretty small, tight area here, okay, you have something moving towards you, okay, and something moving away. Okay, what does that mean? It means rotation. And, folks who are looking for tornadoes, looking for troubled spots, they get real excited when they see rotation. So on the next slide, actually, we're going to call that a tornado vortex signature, TVS, tornado vortex signature. Okay, this actually over here, this regular radar, let me go ahead and give you a heads up. A cool thing with regular radar is it sometimes can give you what's called a hook echo. And I don't know if this kind of looks like a hook, okay? But a hook echo from regular radar actually is oftentimes showing you the wraparound of your supercell. And in the middle there, you're going to find your hail shaft and you're going to find your tornado. So hook echo over there, and tornado vortex signature over there. Okay, so regular radar gives you a hook echo, tornado vortex signature. I can never remember what that is. But that's the whole red-green thing coming from Doppler radar. So those are two things that meteorologists get really excited about. Can't blame them, right? So you can kind of see the hook is kind of drawn out there. Notice that this is showing, the caption says that it was a series of supercell thunderstorms that came through. And so remember, supercell thunderstorms are good candidates to give you tornadoes. Not necessarily. So let's look at that's regular radar, and this is Doppler radar. So kind of within the hook, you put those two together, and you got that tornado vortex signature. The rotation within the precipitation.
Whoa.
Yeah, that's a pretty one.
That must be where the Doppler is.
Yeah,
Radar is.
yeah. It's the whole spiky thing you kind of see on the regular radar image on the left there. That actually is kind of a false signal coming from kind of just the surrounding area, too close to the radar itself. But you see the tornado vortex signature over here.
Midwest city. What a bad Midwest city.
So just to finish up, chasing tornadoes, right? Right. Actually, I have a video. I think it's like a 20 minutes is the segment I want to show you. So we're going to start with that after break. After these last two slides.
Oh.
So I don't know about you, but I swear I've seen that one on the left. I've seen one of those trucks. Okay, National Weather Service. I mean, they can be deployed out to places where the outlook looks like they're going to have, storm cells. And this caption down here, can you guys see the wall cloud here? Dropping down from the base of the cumulonimbus cloud. And there's a Doppler radar. Everybody wave to the Doppler radar. Doppler radar on wheels.
It's like the World Cup trophy.
These little dots are showing you where, it says locations of the National Weather Service.
So we have two.
So you guys said you get yours from
Quad Cities. It's the right.
Quad Cities? Yeah, we get ours from Quad Cities. And you said St. Louis?
Yep.
Or I still heard some sort of.
Sometimes
Springfield.
Springfield, that's what that is. Okay. Break time, 10 minutes-ish, 6:35-ish. And like I said, we'll start out with a video. How's that? I like it.